now we are discussing this part. Protocol for noiseless channel and for noisy channel. So noiseless channel means here we consider that there is no effect of your message signal of your noise. Noiseless is actually practically impossible, but still on that type of concept is used. Noiseless channel means error free, totally error free. And another one is a noisy channel where we have some possibility of noise. So these two category, for noiseless channel we have the simplest and stop and wait protocol. And for noisy channel we have stop and wait ARQ, go back, this is not hack, this is back, BACK, go back and ARQ, and selective repeat ARQ. So we are discussing these 5 protocols here. Okay, for noiseless channel it is very easy one, but for noisy channel here we require, and it is important for exam purpose also about the ARQ concept. So we are discussing here one by one. So see, what is called noiseless channel? See, so already I told you now, there is no concept that your data frames are lost or corrupted or any noise effect is zero. So it is introduced as your noiseless channel. So simplest protocol. The normal concept, whatever the user send, it is received by the receiver. Because we already consider that this protocol applicable for your noiseless one. So you see, this is called simplest. For simplest protocol, this is the design. That means you are sending some data frames and they are receiving all the data frames in correct order or with there is no data loss. This is the design for your simplest protocol. Okay, from sender side, data packets are, these are data frames sended, and in receiver side, we assume that all frames are received correctly. And there is no concept for data loss. That is called noiseless channel. But practically it is impossible. Okay, and there is no, since there is no data loss, so there is no concept for your retransmission of your frames. There is no retransmission of frames. Whatever we send, it is received by the receiver. We think like that. Okay, so this is simplest one. It is not asked in your examination. Simple concept: sender send and receiver receive all the data frames without any error. But you see here, all the, for every protocol we have these types of algorithm. The normal one, we have to send the data and receiver receive the data. There is no concept for acknowledgement or retransmission. Okay, so like this type of this algorithm is never given in your examination. Just they ask what is called ARQ or what is selective repeat ARQ or what is stop and wait ARQ, like that. So it is in syllabus, that's why I just started from your noiseless. Otherwise noiseless is never given. So next one, your this is the concept. Next one, stop and wait protocol. From their name you can make some idea what is called stop and wait protocol. Okay, so see, we are all discussing for your noiseless channel, and if you see the design, then you can make an idea. Some procedure for your acknowledgement for each frame. You are sending your data frame, from that side they retransmit your they send your acknowledgement frame. Sender send the data frame, from receiver side they send the acknowledgement frame. This is the concept for your stop and wait protocol. They wait until they are not receiving the acknowledgement. If they receive the acknowledgement frame from the receiver side, then they again transmit the next frame. Are you getting the point for stop and wait protocol? Anyone please reply?
Yes,
Earlier in simplest protocol, there is no concept for acknowledgement because we already consider whatever data packets are sent already that is received. Next one, the same, almost same, but here we are introducing another concept that is called acknowledgement frame. That is from your receiver side. You can see the arrow marks. Data frame are coming from your sender side and receiver from receiver side. You can see the acknowledgement frame. You see the black line arrow marks. Arbas, okay, you want to tell something?
no, ma'am, I don't have any questions.
Huh?
No, ma'am, I don't have any questions.
Okay, this is a simple one. Anyone in these two protocol, stop and wait, and this sorry, simplest one?
No, ma'am, no question.
Yeah? See, the stop and wait protocol, why it is called? Because the sender send one frame, stop until it receives confirmation from the receiver. Okay, then send the next frame. That's why it is called stop and wait. It's send, then stop, then they stop up to which point? Still they are not receiving the acknowledgement. If they receive the acknowledgement, then they again transmit the next frame. Here also there is no that type of concept of error or means noise. That's why it is indicating as your noiseless channel. So these two concepts applicable for your noiseless channel. Simplest one, no acknowledgement, stop and wait, we have acknowledgement, but still we consider as a noiseless one. Okay, and you see the design. This is, see, whenever that type of question is given, maybe for stop and wait, or maybe selective repeat ARQ, in any concept, you have to draw this diagram. Okay, you have to draw some frames which are sending from the sender side, and from receiver side also you have to draw some acknowledgement frame. So all you have to represent in diagrammatic form, and you have to write down like this: network layer, then their data link layer, then the physical layer. So data are sending from network, data link, and then physical, then they pass to the receiver side, and from receiver side the acknowledgement frame is again passed to in reverse order, from physical, then data link, then network, like that. Are you getting my point? So you have to, don't confuse in their arrow marks. This second arrow marks for this acknowledgement frame, and the first this arrow mark for your data frame. They are different. Data frame and acknowledgement frame are different. One is from sender side, another one is from receiver side. Okay. So you have to draw in this way in your examination also. Now we proceed to your noisy channel. Okay. Now you see what is noisy channel concept. Here you can see at earlier one we have only one condition, while, always true we consider, but here we have one condition, if. If your acknowledgement is received, then only they can again retransmit in stop and wait. Here we have while and if. See, noisy channel. So here we have concept for your what? Noise. And here we consider that there may be some error or we have some data loss, like that. So here we introduce one concept that is called ARQ. ARQ means automatic repeat request. So for noisy channel, your first protocol is stop and wait ARQ, automatic repeat request. So see, in case of your stop and wait ARQ, it's a simple error control mechanism to the stop and wait protocol. The concept is same one, like your earlier one, stop and wait. But here they introduce one error control mechanism. But in earlier case, there is no error control mechanism. So what is a means that error control mechanism, how it works, you can see this one. Here they maintain some sequence number. If you see the diagram, then it is very easy one. So for each frame, they are assigning some frame numbers. In next slide, I will show you the clear diagram. Today, actually, I have some hurry, that's why I have to show here in your that. Next class, I will show you some means clear diagram for this stop and wait ARQ. So see, for each frame number, they have some acknowledgement. For each frame, they again send acknowledgement, receive the data frame, send the acknowledgement like this. So they maintain some sequence number. Okay. So here we have two number. One is called sequence number, that is for data frame, and another one is called acknowledgement number for the acknowledgement frame. You can view this diagram now. You means it is visible or not. Here you see data frame. So in that data frame, you can see your sequence number and your acknowledgement number. For each data frame, some acknowledgement number is there. So if they are not receiving that acknowledgement for a particular data frame, then they do what? Then they retransmit that frame. Okay. Suppose they are sending frame number 1, data frame number 1, data frame number 2. For 1 and 2, suppose they are means finding the acknowledgement. So see this one. In stop and wait, the acknowledgement number always announces in modulo 2 arithmetic the sequence number of the next frame expected. Okay, so how it is work? See, suppose the sequence number must be suitable for both data frame and acknowledgement frame. The acknowledgement number always announce the sequence number of the next frame. That means suppose you are sending frame number 1. So from their side, so see, if frame number 1 has arrived safe and sound, the receiver send an acknowledgement frame with acknowledgement 0. That means their numbers is different. Suppose you are sending frame number 1, so your acknowledgement number is not frame number 0. Sorry, not 1, it is 0. If you are sending data frame number 2, they are sending acknowledgement number 1. If you are sending data frame number 3, acknowledgement number should be 3, like that. Sorry, 2. 1 is less. In acknowledgement side, 1 number is less. They're starting from 0, like that. That's why it is, if you, I can draw this, that is more suitable for you to see also and for understand also. But from here, you can means make some idea. Okay, just you means there may be some possibility that from after few days your college will be here. For the time being, just you remember here, whatever they send, for each frame they have one acknowledgement number. This is one point. Another point is that while they send a data frame, they keep a copy of that sending frame in sender side. Suppose they send data frame number 1, but for that data frame number 1, they have one copy in sender side. And they have some timer. Timer means suppose for 2 minutes or 3 minutes, wait for the acknowledgement. After 2 or 3 minutes, if that acknowledgement number is not received by the sender, then they do what? Retransmission. Okay, so see, error correction stop and wait ARQ is done by keeping a copy of the send frame and retransmitting of the frame when the timer expires. Okay, so it is not like that they send the data frame, after that there is no data available for that sending frame. It is not like that. They keep a copy of that data frame after transmission to the receiver also. If they are not receiving the acknowledgement from the time receiver side for a particular time period, then they again retransmit it. Are you getting? Means you just remember, where you have the concept of ARQ, you have the facility of retransmission. If you see the ARQ related with any of the protocol, just you make one idea that they make the retransmission. But their retransmission mechanism is different for different protocol. You are getting something or nothing?
Yes, ma'am. Getting.
Something, Sankhanan?
Yes, ma'am.
Aziman क्यों
Something.
देरी
I'm very.
ना? और इसी तरह for a specific time, if the acknowledgement is not received from by the sender, then they again retransmit it. See, if the timer expires and there is no acknowledgement for the sent frame, the frame is resent, the copy is held, and the timer is restarted. The timer is restarted for the next data frame. That's why it is called ARQ. ARQ means here we have so many conditions. We have to set some condition for acknowledgement also. We have some set condition for data frame also. Okay. This one. Suppose this is your flow diagram for your stop and wait protocol. They send frame number 0, so they receive frame means acknowledgement number 1. Then they suppose frame, while they transmit, that data frame is lost. Then again they retransmit the frame number 1. While they lost any of the frame, then they retransmit it like this. Retransmission is that. So go back and ARQ is somehow complicated. So here we have one concept that is called sliding window. Sliding window. In your examination, normally this is given sliding window. Sliding window, what is called sliding window like that. That is very important also. So here, in case of your go back and ARQ, we have to maintain your sequence number like this. 3, 4 like this. 2 to the power m minus 1. Okay. Where m is the number of bits. So suppose if m is equal to 4, then you have to maintain how many frame number? 2 to the power 4 minus 1. So 16 minus 1 equal to how many? Maximum number assigned should be 15, but you have 16 number of frames. So here you can see, in go back and ARQ, your sequence number are like this. For 4-bit number, 0, 1, 2, 3, 4, 5, 6 up to 15. 0 to 15, how many numbers are there? 16. So you have to maintain your sequence number up to 15. Again they make the repeat of same series 0, 1, 2, 3, 4 like this up to again 15. Okay.
Yes, ma'am.
So this is the means sequence number in case of your go back and ARQ. But here we have some that is called sliding window concept. Sliding window. Sliding window means through window we can view only a particular part of the outside. Yes or no? Means if you slide one part of window, that some particular part of the outer area you can cover, not the whole area. Similarly, here maybe you have 16 number of data frame, but for a particular time interval, you are concerned only for some frames. Are you getting my point? What is called sliding window?
Yes, ma'am.
Yes, ma'am.
This you have to study also. Again, if you return, then again you can discuss. But student normally the sliding window find very difficult. The concept means while we slide the window, then we can view other part of the outer area. So here, while we send the sequence, while we send the this data frame, as we are sending, we are more familiar with the other data package also, other data frame also. So here you can see in go back and ARQ. Today I am not discussing the whole part, just to see some of the term that we are using in go back and ARQ. What are the term you see? One part is called send window. Send, SEND, send window. One part is called receive window. This part, this diagram. This diagram for your receive window. So here, today, in your this book, this frozen book, in page number 323, you try to see what is called sliding window. I already explained, but I don't know. Earlier also, while I discussed this topic, sliding window is very complicated for student. But if you see for few minutes, means with the diagram, if you try to relate that one, the description with the diagram, then I think you have some idea. Then tomorrow I will discuss more detail about the send window and your receive window. Here you can see we are dividing some section. What is the send window size? 2 to the power m minus 1. Okay, that means ultimately we have 15 number of frames, but here we have some other division. So it is more suitable for practical, physical class, not in online class. I have to draw first this section, then go to, and you try to see what is called this window, sliding window concept. Later on you can understand what is called your sending window, what is called receive window, like that. Means anyone get some idea what is called sliding window? I just explain, but I don't know whether you got that one or not. Sliding window. From this diagram, you can see. From this diagram, if you see the whole rectangular section, here you can see so many data frames are there. 13, 14, 15, after 15 again it started from 0 up to again 15. But we have several sections. So for this given example, if you consider m value equal to 4, our send window size will be 2 to the power m minus 1, that is 15. So there may be other frames in our that series, but we are concerned with this only 15 numbers. Are you getting? I don't know, you have to see that one. Because you are not replying also, that is another problem. Roshni,
Yes, ma'am.
today you see that one in your book.
Ma'am.
Same window, I already mentioned. For this example, this is not always true for all the data frames. Here we consider a specific value where we are considering m equal to 4, and that's why in this same window we are considering this 15 number of data frame. If m value is different, then same window is different. If again m value is 3, then your same window size will be different. Anyway, you try to see this one. In go back and ARQ. This is not A and D, this is N, capital N. Go back and ARQ. Arbaz?
Yes, ma'am.
Hello, Arbaz?
Yes, ma'am.
Today you see this one, you try to read little bit. Tomorrow again we discuss the same topic.
Okay, ma'am.
Okay, just slight different one, and this sliding window concept also there. Then we again discuss the same topic. Go back and ARQ. Your this what project guide list.